Hi guys, I'm Kenny. This is my presentation on ice fishing for neutrinos, which was the physics lecture I attended for this physics semester. So the first thing the presenter did, which really helped out a lot, is he gave us a little background on neutrinos. So to start off, neutrons and protons switch their identity back and forth during nuclear reactions. A neutrino is the fourth particle and makes nuclear physics possible. A neutrino is what balances the reaction in nuclear reactions. And, there's everything from accelerator beams, nuclear reactions, the Earth, our bodies, the sun, stellar explosions can be used to actually make neutrinos. So when you, for example, like in the case of an accelerator beam, when you accelerate protons and hit the target, they intermix and interact, and neutrinos exit the sealed target. It's also important to note that neutrinos have no charge and do not interact. Therefore, they can't be stopped by the sealed block. It's also true that neutrinos have... Neutrino is the ideal comic messenger because they are neutral, massless, non-absorbable. They can also be used to track the nuclear process, but they are difficult to detect, which is kind of the whole basis of this presentation. So this experimental group first noted that blue light travels 100 to 300 meters through the ice, which is the clearest solid produced in nature. And they also knew that particles produced in a nuclear reaction produce blue light in water. So, what they did is they actually went down to the South Pole to conduct this experiment. But it was actually an experiment on muons, which makes this whole thing very ironic. So what they did is they built a particle detector at a station in the South Pole. And they got the funding for their project, and they began to drill through the snow, and then used a hot water drill to go further. And after 2 days, we're about 2.5 kilometers into the ice, and there they built a hole. And so where you drill the actual hole is where you're going to put the power plant. And so what the whole experiment is, it took current, digitizes it, and sends it to the computer. And so again, I talked about this whole experiment was on muons. And so they were looking for muons, trying to detect them. And instead, they detected the neutrino, which is extremely exciting because they did not expect this at all, and it was actually supposed to be insanely difficult to do it. And for that reason, it was the physics breakthrough of the year in 2013. And so from this, they were able to really determine that neutrinos come from the sky. And, previous conception was that stars collapse and all their energy is given to accelerating particles, and this is where neutrinos come from. However, this experiment actually proved that was not necessarily totally correct. And another really cool thing about this is the first neutrino was actually detected 1 degree from the center of the galaxy. So from this standpoint, this is an extremely exciting experiment where they went in looking for something else and actually had this incredible breakthrough that they actually found by accident. And so from this standpoint, it's interesting to conceptualize what else is out there, because it's very kind of, the possibilities are limitless and stuff, and there's still many things we don't know, such as dark matter, dark energy. And you wonder about how many discoveries may come along where we're looking for something and we actually find something else. And that goes back to the Rutherford experiment and the discovery of the neutron and all sorts of different things. So it is an exciting time and stuff to think about what else we will be finding out there, and only the future will tell. So thank you for listening, and I hope you learned something from that.